In 6.0, we will talk about the properties of exponents. If there's one section that you really have to focus on in college algebra, it's the properties of exponents. Because when you get to calculus, whether it's business calculus or calculus 1, exponents are an integral and essential part of calculus. And without the knowledge of exponents, without a strong knowledge of exponents, calculus is going to be extremely hard to tackle. So let's revisit the properties of exponents, and I do encourage you to put like a bookmark for this video or for this section, and before you take calculus, please come back and revisit this because, like I said, when you get to calc, they're going to assume you know exponents, and if you don't, you're going to be lost. Okay, so let's talk about some rules of exponents. First one is a product rule. The product rule says that if you multiply two terms with the same base, then you add the exponents. Okay, so if you have a to the m times a to the n, that equals to a to the m plus n. So first we're going to look at the rule, and then we're going to see why does it exist. So we have x squared times x to the fifth, and our natural instinct might be to see this multiplication sign and add and multiply the 2 and 5. However, because we are using properties of exponents, when you multiply the same base, you actually add the exponents. So x squared times x to the fifth, this is going to be x to the 2 plus 5, which is x to the seventh. And I know it's easy just to, do this in your head, but I do encourage you to write out your work because the more you write out your work, the more likely you are to remember these rules and properties. So this is going to give you x to the seventh. So that's how you do it. Now, why is this true? Well, x squared, it means you have your base x multiplied 2 times. X to the fifth, it means you have your base x multiplied 5 times. So how many x's total are we multiplying together? We got 1, 2, 3, 4, 5, 6, 7, which is how we get x to the seventh. Okay, so if you multiply the same base, add the exponents. Let's take a look at the next example. We got x to the 2/3 times x to the 1/2. So same thing. You keep the base, and you always keep the base. The base does not change. Notice that these x's magically didn't become y's or something like that. So you always keep the base and add the powers. So we have 2/3 plus 1/2. Now we're going to have to go back and revisit fractions really quickly. So if you have 2/3 plus 1/2, we need to find the least common denominator. And here's the best way to find the least common denominator if if they're bigger numbers or whatever. You start listing out the multiples of 3, so that's 3, 6, 9, 12, etc., etc. Multiples of 6, that's 2, 4, 6, 8, blah, 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 blah. And you find the first number that 3 and 2 can both go into. So 6 is the first number that 3 and 2 are both factors of. So our least common denominator is going to be 6. And then when you rewrite the fractions using a denominator of 6, we got to think about how do we go from 3 to 6? What do we multiply by? Well, we multiplied by 2, so we multiply the numerator by 2. And this first fraction, instead of 2/3, becomes 4/6. And I hope that makes sense because 2 out of 3 is same thing as 4 out of 6. And then same over here, you have 1/2. To change the 2 into a 6, we multiplied by 3. So we multiply the 1 by 3, and this gives you plus 3 over 6. We can only add fractions once they have a common denominator. So now we can add 4 plus 3, and this will give you 7 over 6. So this becomes x to the 7 over 6 power. Now, if you need help with adding, subtracting fractions, there are lots of YouTube videos on adding, subtracting fractions. You can email me, and I'll be happy to recommend some to you. Okay, so the first rule says if you multiply the same base, keep the base, add the powers. The power rule of exponents says if you have one base but two exponents, so if you have a to the m and that whole thing is raised to the nth power, then you multiply the a times n, the m and the n. Okay, so if you have a power to a power, which is why it's called the power rule, you multiply the two powers. So if you have x to the 3, x cubed raised to the 4th power, by the power rule, you're going to multiply 3 times 4, and this will give you x to the 12th. This is different than the product rule. Sometimes, they get confused. In a product rule, you're multiplying two bases that are the same. Therefore, you add the exponents. In the power rule, you only have one base but two exponents. And that's when you multiply the two exponents together. The next example, we have x to the 2/3, and that's all raised to the 1/2 power. So again, by the power rule, we got one base and two exponents. So by the power rule, this is going to be x to the 2/3 times 1/2. And that looks like a subtraction sign, but it's actually multiplication. Now, adding fractions requires a common denominator, but multiplying fractions does not. In multiplying fractions, all we have to do is we have to multiply the numerators and multiply the denominators. So we have 2 times 1, which is 2, and 3 times 2, which is 6. And of course, every fraction has to be reduced, so we can divide these both by 2, and this gives you x to the 1/3. Another way you could have done it is you could have cross-canceled. You could have said we got a 2 and a 2, so we cross-cancel those, and we once again are left with 1/3, which is x to the 1/3. You can do whatever way is going to be easier for you. Okay? You cannot cross-cancel in addition. So like in addition, I can't just cross out the 2 and 2. Only in multiplication can we cross-cancel. In adding and subtracting, the only way to do this is to get a common denominator, rewrite each fraction with a denominator of 6, and add the numerators at the end, once we have a common denominator. Okay, the next one, it says product to power rule. So this one says, if you have a parentheses with multiple terms, and that whole thing is raised to the 5th power, then each individual term is going to get raised to the 5th power. So we're going to rewrite this as x to the x cubed raised to the 5th power, and y to the 4th raised to the 5th power. So here we get 3 times 5, which is x to the 15th. Here we get 4 times 5, which is y to the 20th. Now, why do we use the power rule here? Because you got the same base and two exponents. When we got the same base and two exponents, we are going to use the power rule, in which you multiply the two exponents together. Same thing for the next one. We're going to rewrite this as, so you have two terms in a parentheses, and that whole parentheses is being raised to the 1/2 power. So by the product to power rule, if you have a product inside a parentheses, and that whole parentheses is raised to a power, then this is going to equal to x to the 3/4 raised to the 1/2 power times y to the 2/3 raised to the 1/2 power. Okay, so let's multiply these together because you have the same base but two exponents. So this is going to give you x to the 3/4 times 1/2 times y to the 2/3 times 1/2. Okay, let's simplify this. We have 3 times 1 is 3, and 4 times 2 is 8, so this gives you 3/8. Now here, I'm going to just cross-cancel the 2's to make my life a little bit easier. So I'm going to cross-cancel the 2's, and I'm left with y to the 1/3. So essentially, I multiplied 3/4 times 1/2 because you take a power to a power, you have the same base, that means you multiply the exponents. So 3/4 times 1/2, that gives you 3/8. 2/3 times 1/2 gives you 1/3. All right, now the quotient rule, sorry, got cut off a little bit, but it says if you have a to the m divided by a to the n, that equals to a to the m minus n. So we keep the base, and we always subtract the exponent of the numerator minus the exponent of the denominator. Okay, so once again, you keep the base, and you subtract the numerator minus the denominator as far as exponents go. So according to this rule, we're going to keep the base. We're dividing the same base, so we keep the base. And then we subtract the 5 and 3, and then this gives you x squared. Okay, so that's the how. Now why? Like, why do we do this? Well, x to the 5th, it means we have 1, 2, 3, 4, and 5 x's. X cubed, it means we have 1, 2, and 3 x's. So anytime you have x divided by x, that gives you 1, 1, and 1. So we have x times x, which equals to x squared. So when we're dividing, we're canceling out terms, which is why we subtract the 5 and 3. So similarly, let's take x to the 2/3 divided by x to the 1/2. We got the same base, and we're dividing the two bases. So by the quotient rule, we're going to take 2/3 minus 1/2. Now on the side, let's work this out. We got 2/3 minus 1/2. Our common denominator, once again, is going to be 6. So we're going to take the 3, rewrite that as a 6, take the 2, rewrite that as a 6. Then we got to think about what do I have to multiply each term by? So the 3 is going to get multiplied by 2, which means the 2 gets multiplied by 2, we get 4/6. The 2 gets multiplied by 3, and the 1 gets multiplied by 3. So we get minus 3/6. And then 4 minus 3 is 1, which gives you 1/6. Okay, so if you divide the same base, subtract the exponents. Now, here is the rule with negative exponents, and this is something you're going to be using quite a lot. If you have a to the negative n, that equals to 1 over a to the n. Okay, so usually with exponents, we don't write our answer using negative exponents. So anytime you have a negative exponent, we're going to use this rule. It's going to move to the denominator, or if it's on the denominator, it's going to move to the numerator, and it'll become positive. Okay, so for example, let's say 5x, we have 5x to the negative third. So just keep in mind that this is actually 5 times x to the negative third. So the exponent, it only goes to the term that's directly beneath it. It does not go to the 5, unless the 5x was in parentheses, but it's not. So the negative 3, that only belongs to the x and not to the 5. So we have 5 times x to the negative third. So the 5 stays where it's at. X to the negative third moves to the denominator, and it becomes x cubed, and this becomes your final answer. Okay, so we have x cubed divided by x to the 7th. By the quotient rule, if you divide the same base, you subtract the powers. So we have 3 minus 7, which is x to the negative 4th. Our final answer cannot be written using a negative exponent. So we are going to rewrite this. Well, if you have a to the negative n, it equals to 1 over a to the n. In other words, you move this to the denominator, so this becomes 1 over x to the 4th. Now you probably have some questions by this point, and that's totally fine. Just keep those and ask me in class. Next, we got rational exponents. So rational exponent, the word rational refers to a fraction. So rational exponents are when your exponent is a fraction. So let's say we have a to the m over n. The denominator n, it becomes the root, and the numerator m, that becomes the exponent. Okay, so if you have a to the m divided by n, the n becomes the root, and the m becomes the exponent. So if I were to rewrite the fifth root of x cubed, then I know that the root is the denominator and the exponent is the numerator. So this is going to be equivalent to x to the 3/5 written as a rational exponent. The exponent becomes the numerator and the root becomes the denominator. Okay, let's take a look at cube root of x to the 15th. So once again, the exponent becomes the numerator and the root becomes the denominator. But we can actually simplify 15 divided by 3, so this gives you x to the 5th power. Now we want to go backwards. We want to write this in radical form. We have x to the 4/9. So once again, the denominator is going to become the root. So we have the 9th root of x, and the exponent becomes, or the numerator becomes the exponent. So we have the 9th root of x raised to the 4th power. Okay, similarly here, the denominator is 7, so we know we have the 7th root of x, and the numerator is 12, so we got the 7th root of x raised to the 12th power. Now in the next section, we're going to apply these and just do a million examples. And as I said, this is going to be super important in calculus, so we have to make sure that we get a good foundation of this concept, properties of exponents, in college algebra. So the next video will take us through some examples.